So our notes are going to follow in the Unit 2 notes. So if you guys want to go to that. And the last thing that we did, and remember we did just take a quiz, but in that Unit 2 notes, we had up here, this was the solving by quadratic formula stuff. And then after that, we had some application problems, but we did the free falling object stuff. So that was in a different note section. So I'm scrolling down here to where it says 3.1 quadratic functions. And we're going to take a look at this particular quadratic function. So if you're lost or you don't know where we're at, just please speak up and I'd be happy to give you guys a little bit of guidance. But we're going to look at quadratics first in vertex form and then in standard form. So this equation, f of x is equal to x minus 1 quantity squared plus 4, that is in vertex form. As opposed to standard form, I'll get to that in a minute, but let me just scroll down to show you. This is standard form, okay? So when it's 2x squared plus 4x minus 6, that's standard form. This thing is in vertex form. And the reason we call it vertex form is because it's real easy to find the vertex. You get the x value from here. It's whatever makes that 0. A lot of times when you have parentheses, the thing that makes that equal to 0 is significant, meaning number 1 is the x value of the vertex, and then this is the y value of the vertex. So the vertex of that particular parabola is at 1, 4, okay? And that could be seen right here. So the graph is given to us. There is the vertex. Now the axis of symmetry, that means the axis, that's the line that cuts it in half. So if you think about like this, and I didn't draw that very well, sorry. This orange line cuts that graph in half. And the orange line is a vertical line, which goes through the point 1, 4. And so the equation of that line is x equals 1. So the axis of symmetry, when it says axis of symmetry, remember it's a line, so we want to say x equals, and it always goes through the x value of the vertex.
Wait, why does it equal 1?
Because the coordinates of the vertex, it goes through
1, 4.
Yeah, it goes through the point 1, 4. So it's the vertical line x equals 1.
So it's always the axis of symmetry is always the x-axis.
Correct. Assuming it's a function like the parabola opens up or down and not open to the side. We're not going to do those. Those would not be functions. So that would not be part of this section. So it is always, to answer your question, always the x value for the axis of symmetry. Now, the y-intercept, to find the y-intercept for any particular function, you always set x equal to 0. So for the y-intercept, we set x equal to 0. And as long as I'm writing, for the x-intercept, we're going to set y equal to 0. So we should be able to find, I'll do the y-intercept first. To find the y-intercept, I'm going to take that equation and set x equal to 0. So that means I'm plugging a 0 in for x there. So we get 0 minus 1 quantity squared plus 4. So again, I got that by plugging 0 into there. So that's going to be 1 squared plus 4, which is 5. And so my y-intercept is at 0, 5. And that really does correspond to the picture we have over here since we were given the graph. There's the y-intercept. The y-intercept is where it hits the y-axis, which is at 0, 5. So the algebra matches up with the graph. Now to find the x-intercept, we set y equal to 0. This is going to take a little bit more work because the y is the output. We're going to set that equal to 0. So we have to solve the equation 0 equals x minus 1 quantity squared plus 4. All right, so we want to solve this to find the x-intercepts. So let me start to do this. I'll move the 4 over. So this goes back to what we were doing in the last section. You know, we can isolate this part. So move the 4 over. So we have negative 4 is equal to the quantity x minus 1 squared. Now we take the square root of both sides. So we get plus or minus the square root of negative 4 is equal to x minus 1, where x equals 1 plus or minus 2i. So notice I wrote that square root of negative 4 as 2i. So you know what that means for x-intercepts? There are none. Okay, because we got imaginary numbers or complex numbers. And look at the graph up here. It never hits the x-axis. The x-axis is way down here. The graph never touches it. So there's a case where the algebra, of course, and it should always, the algebra should make sense with the graph. It doesn't have any x-intercepts. We know that because we got complex numbers algebraically, verified by the graph here, never touches the x-axis. All right, the domain of this function is all real numbers. It's from negative infinity to infinity. Remember, to find the domain, we squish all of it onto the x-axis. Okay, so the entire x-axis would be covered up. So the domain is going to be all real numbers. The range, if we squish everything onto the y-axis, well, the lowest the y-axis comes down to, the lowest the y values come down to is right here at 4, which is why that y value of the vertex is so important, because that gives us a cutoff point for the range. So the range is inclusive of 4 to infinity. All right, any questions for me yet?
How do we wait if they don't have any dots or anything? Is it always inclusive?
If there's no open circles.
Oh yeah, if there's no open circles.
Yeah, I think that's what you meant. Yep, no open circles, right? So it would be.
I have a question.
Yeah.
So for the x-intercept, since it's plus or minus, shouldn't there be 2 solutions?
Well, there are 2 complex solutions. However, there are no real solutions because it never touches the x-axis. As opposed to, maybe this will make more sense, when we do this problem down here, see it crosses the x-axis twice, we will get 2 real solutions for that one. But in this case, it never crosses the x-axis. So we do get 2 answers, but they're 2 complex answers or no real solutions. All right, great questions, guys. Anything else? All right, well, a little bonus things we could talk about. Remember, we did intervals where things are increasing or decreasing. Like if I said, all right, where is this thing increasing? Well, it's increasing right here. That would be from this x value, which is 1, of course. And again, why that vertex is so important. It's increasing from 1 to infinity. And the function is decreasing. It's decreasing here. So it's decreasing from negative infinity to 1. So remember, when we write those intervals, we're using the x values. So just to tie into some stuff that we did before when we were talking about domain and range, increasing, decreasing. We did some of that with our parent functions and some transformations and things like that. So that's kind of coming back to what we're doing now. All right, so in this case, we were given a graph over here. Now we're going to do one where we're not given the graph. We're going to determine that information from the equation. So this is written in Vertex form, and while we're writing things down, I'm going to be graphing at the same time, okay? So this is written in Vertex form, which, let me fill in this box here. Vertex form is when you have y equals a times x minus h squared plus k. So in that form, the vertex is hk. The x value comes from here. The y value comes from here. So looking at this problem number 3, our vertex is at 1, -9. So let me graph that point while we're talking here, and so I don't forget. So I'm going to go to 1, -9.
Is this like how we did last unit where we had to like graph it with like what we got?
Right, from given information. Yep.
Yeah.
So we have a vertex at 1, -9. The leading coefficient is +1. That means it's going to open up. So I already know, I don't know how wide it is just yet. I'll talk about that in a second. But I know it's going to open up, meaning, getting back to Melissa's question, I'm going to get 2 x-intercepts in this case. Because if our vertex is down here in the 4th quadrant, and I know that because that's in the 4th quadrant, and I know that it opens up because the leading coefficient is positive, it has to hit the x-axis twice. So I know that I'm going to get 2 x-intercepts. All right, well, let's find out what those are. The x-intercepts, remember, we find when y is equal to 0. So I'm plugging a 0 into there. So I'm going to solve 0 equals x minus 1 squared minus 9. So let's solve this thing. Move the 9 over. I have 9 equals the quantity x minus 1 squared. Take the square root of both sides. So don't forget the left side is going to be plus or minus. That's where we get our 2 answers. And the right side is x minus 1. So my x values are going to be +3 plus 1, which is 4, and -3 plus 1, which is -2. So I have 2 x-intercepts. They're at 4 and -2. So I'll put those here, one at 4, one at -2. And now that really makes sense to me for a variety of reasons. Number one, I know, I'm going to draw in the picture. I know the vertex is down here at 1, -9. And if the vertex is at 1, -9, my axis of symmetry has to be right here. Which, as long as I'm writing that, I might as well write is at x equals 1 for my axis of symmetry. And looking at my x-intercepts, here's a nice way you can kind of double check your algebra. They have to be equidistant away from the axis of symmetry because the parabola is symmetric. So they both look like they're same distance away. In fact, they are both 3 units away from the axis of symmetry. So I feel really good that I did the algebra correctly. And I have a nice picture of the graph. Let's do the algebra for the y-intercept. Remember, the y-intercept is when x equals 0. So I'm going to plug a 0 in for x here, and we'll get 0 minus 1 quantity squared minus 9. And so that's 1 minus 9, which is at -8. So as a coordinate, our y-intercept is at 0, -8. Well, look at that. That point is right there. It makes sense and checks out with our graph right here at 0, -8. So both these things and this thing, the algebra and the graph, of course, should reinforce each other. All right, any questions on how I found any of that stuff? All right, our domain is all real numbers. So from -infinity to infinity. Our range is from -9 to infinity, inclusive of -9. And I know that the lowest y value is -9 because that's the vertex. So again, kind of a double check, looking at the vertex. I look at the graph here, is at -9. And just for good measure, I'm going to write down the interval where this graph is increasing. It's increasing from here to the right. So that part is increasing. So that means that like in this section, it's increasing. So that would be from 1 to infinity. So we write down the x values. And it's decreasing here for x values from -infinity to 1. All right, so I don't know if you're still writing there, but we can, learn a lot from just understanding where the vertex is. We know which way it opens. So for example, just looking at this problem right here, I know the vertex is at -2, -1. I know the vertex is at -2, -1, which is in the third quadrant down here somewhere. I know that graph is going to open downward. So let's piece that together. If the vertex is in the third quadrant and it opens downward, there will not be any x-intercepts because it's got to be like this. So I know that if I did this, I would get complex answers. Now looking at problem number 5, this says, how many real solutions does this have? Well, remember, real solutions and roots and x-intercepts, those all mean the same thing graphically. So this question is saying, well, how many x-intercepts does it have? Well, let's take a look at the equation. The vertex would be at, our x is at 3.2 and our y is at 18.5, meaning this vertex is in the first quadrant. To the right 3.2 and up 18.5. It's in the first quadrant. It's going to open upward. Therefore, how many real solutions does it have? None. How do we know? Well, we know that the vertex is in quadrant 1 and it opens up. So, if it looks like that, it can't have any solutions, any x-intercepts.
Why is that?
Well, we know the vertex is in the first quadrant. because it's at positive 3.2 and positive 18. Both the X and Y value are positive. You with me with that?
Yes.
Okay. So if it's in the first quadrant, the vertex will be over here somewhere. And it opens upward because their A value is positive. So the vertex is there and it opens up. It cannot hit the x-axis.
Got it.
If this was a negative number, it would open downward, and then it would have to hit the x-axis twice. So you want to look at where the vertex is and which way it opens to see if it's going to hit the x-axis.
So by real solutions, it means like where it hits the x-axis.
Perfect. Yes.
Wait, I know we're not doing number 4, but does number 4 open downward?
It does. How
Okay,
do you know that?
Because of the negative, right?
Perfect. Yep. So it would open downward. Okay. Which is also going to determine, like, if something opens downward, visualize that it has a maximum, right? If something opens upward, it has a minimum. So for this question, it's asking, does this function have a min or a max? Well, I know that it opens upward because that's positive. Therefore, it has a minimum. Now, what is the minimum? Well, the minimum, if it opens upward, is going to be the y value of the vertex, 18.5. So it has a minimum at 18.5. And again, I know that because the vertex is in the first quadrant, it's over 3.2 and up 18.5. And then it opens upward. So the smallest minimum value would be 18.5.
Wait, why is 18.5 the y?
So if you're looking at this, remember our vertex would be at 3.2, the coordinate 3.2, 18.5, right?
Oh, okay. Got it.
Okay. You got it? So then, and then it's going to open upward. So then this would be the minimum value. All right, this is good. Any other questions? All right, so I think you guys are going to handle, of vertex form. So of course, now we have to change things, right? So now I'm going to talk about equations in standard form. Well, standard form, we've been doing actually. That's when something is y equals ax squared plus bx plus c. Okay, just like this guy, 2x squared plus 4x minus 6. That's standard form. Again,
Do we put it into y equals mxb?
Say that again. Mx plus b?
Yeah, do we do that to put it on the graph? Do we need to change
No, because
it?
that would be linear. These are not linear. These are quadratic. So you do not want to do that.
So this standard form is different from the other standard form, which is a plus b equals c.
I'm not following you. I'm not kidding you.
Like, it's not what standard form is usually when you're like doing slope and stuff, right?
Okay, so are you thinking of this? Y equals mx plus b?
No, that's slope.
Correct. Well, that's slope intercept form.
I'm sorry
Correct.
to interrupt. She's talking about the ax plus by equals c.
Ah, this.
Yeah, that.
Thank you very much.
Thank you.
All right, good question. This is standard form of a line because that's linear because your x is to the first power. It's a first degree polynomial. So it is standard form, but that's the standard form of a line. This is standard form of a parabola. Because
So they're different,
yeah, well, they're different shapes, exactly, yes.
but they have the same name.
Well, I mean, you could have the standard form of a parabola. You could have a standard form of a cubic, a standard form of a quartic.
Okay.
They're different degree polynomials, but they are both called standard forms. So yes, they do both have kind of the same name. All right. Thank you for clarifying that, whoever jumped in. That helps. All right. So here's how we find the vertex if something is in standard form. We find the x value by doing negative b over 2a. So in this case, my x is going to be negative 4, that's the b value, over 2 times 2, because our a is 2. So I get my x is negative 1. The x value of the vertex is negative 1. To get the y value of the vertex, I then have to take that negative 1 and plug it in for the x's. So to get the y value, we do 2 times negative 1 squared. I plug the negative 1 into the x here. Plus 4 times negative 1. I plug the negative 1 into the x there. And minus 6. So that's 2 minus 4 minus 6, which is negative 8. So sorry, that's a little small. So to find that vertex, that's a little bit of a pain. You know, if it's in standard form, it takes more time to find the vertex for sure. We have to find the x value by doing negative b over 2a. And then we find the y value by taking the x and plugging it in to the equation.
Is there any shortcuts for that?
There's not, which is why things in standard form are a little more friendly when it comes to finding the, in vertex form are more friendly when it comes to finding the vertex. That's why they call it vertex form.
Is there any way to change standard form into vertex form?
There is, and we'll get there.
Okay.
Yes. All right, really good questions.
Is it easier to convert it than solve it in standard?
No. Not in my opinion. I shouldn't have answered that. I should let you decide. But we'll get to that. There's a process. It does take a little bit of work. All right, but we do have we have a vertex. So doing negative b over 2a, we get the x value, we plug that in to get the y value. So now at least we know we got negative 1, negative 8. That's down here. That's our vertex. I do know the a value is positive still, so it's still 2. So I know it's going to open upward. So I'll have 2 x-intercepts, so that's good. So I'm going to solve the x-intercepts. To find the x-intercepts, that's when y is equal to 0. So I'm going to solve 0 is equal to 2x squared plus 4x minus 6. All right, so again, I plugged a 0 in for the y here. All right, I could solve this a couple ways. I could use quadratic formula. I could try and factor it. Now, when it comes to factoring, remember, you want to give it probably about 20 seconds to try and factor. But if you notice that you can take a 2 out of there, and you've been working on your factoring skills, you might be able to factor that in less than 20 seconds because it does factor into 2 times x plus 3 times x minus 1. which means our x-intercepts are at -3 and +1. So let me put those on the graph before I forget. So x-intercepts at -3 and +1. So it looks like graph is going to look like that.
I have a question.
Yes.
Do you have to solve for the y-intercept if you can tell where it is based off the graph?
Oh, that's a good question. Where do you think it is?
I think it's at -7.
And why from the graph you think it's at -7?
Yes.
All right. Well, I'll tell you what. Y-intercepts in standard form are really easy to do. Because remember, to find a y-intercept, you plug in a 0 for x, right?
Yes.
So plug in a 0 for x. That 0 and that 0, and we get -6. So the y-intercept is actually at -6, not at -7. So to answer your question, I wouldn't do it that way. You'd be kind of risking something that's really easy to solve algebraically just by plugging in a 0 for x. And 0, -6 does make sense with our graph here, by the way. All right, but I love looking for shortcuts, so keep them coming. Our axis of symmetry is the axis that's going to cut it in half. So that's the line x equals -1, which of course is the x value. The domain is all real numbers. The range is going to be from -8 to infinity. And you know, right there, I actually forgot what this minimum value was. So I looked up here and said, oh, it's got to be -8, right? Because that's the y value of the vertex. Some other things that we could say is that this graph is increasing from -1 to infinity. It's increasing here. It is decreasing from -infinity to -1. You know, -1 is the turning point, which of course is the x value of the vertex. It has a minimum value of -8. It's a minimum because it opens upward. -8 because that's the bottom of the vertex. So notice how many times I'm referring back to the vertex. It's obviously a really important point, the turning point of the graph. So to throw just a little more math notation to you, in finding the vertex, remember we did -b/2a, and then we took that number and plugged it into the function. Here's how we would denote that. To find the vertex, we do the x value by doing -b/2a. And then to get the y value, we find f of -b/2a. We're plugging it in for f, or I'm sorry, in for x. So we're kind of doing it like a puzzle where we're piecing all of this stuff together. We did it in two different ways. We did it in standard form on this problem right in front of you right now that we just finished. And we did it in vertex form like the problems above. So any questions on either of those before I have you guys practice a little bit on a Kahoot here?